This is our AWS Deep Racer Training presentation. We are Group A, Team C. Hi, I'm Sarah G. I'm an 8th grader who lives in New Jersey.
Hi, I'm Roger Tang. I'm an 8th grader who lives in Missouri.
Hi, I am Matthew XIE, and I'm an 8th grader from Pennsylvania.
Hi, my name is Ethan Dong. I'm in 6th grade and I live in Ontario, Canada.
Unfortunately, our 5th teammate is sick.
The AWS Deep Racer contest was an amazing experience and really got me interested in machine learning. I think I am speaking for my teammates as well. When I say this experience was extremely enriching, I mean it. I gained a lot of understanding in machine learning and reinforcement learning while making a model for the race. I used a lot of trial and error, trained the model over and over again, and then made tweaks and saw what was wrong to make it better. We analyzed the data of the graph and looked at the video recording to see what went wrong. Based on the data and videos, we changed or added more code to try and fix the model, and compared different models to see which one did better on a variety of tracks. Based on how they did on the different tracks, we picked the best model from there and started extensively training that model and making minor changes to it. We also looked on YouTube for explanations and helpful tips and used GitHub for a sense of direction in the code.
So there were a couple of things I kept in mind while making a reward function. Firstly, we needed to reward it for speed, so obviously speed was one of the factors of the reward function. We also wanted it to stay within the track, so we rewarded it for all wheels on track, as well as distance from center. However, for object avoidance, we needed it to be on the opposite lane from the object, so we rewarded it to stay on the opposite lane more than we rewarded it to stay on the center line. This way, it will avoid objects as well as stay within the track. We also did not want it to make huge erratic turns or wiggle a lot, so we rewarded smaller turning angles. However, we didn't want it to miss the sharp turns, so we weighted staying within the track more than having smaller steering angles. When we started training the model, we decided to use the default hyperparameters. It seemed to work out well, so we just stuck with it when training later models. However, I had to change the action space of the model when I realized that our model was going too fast and would often race off the track before it could even react. To fix this, I first trained it at lower speeds, then slowly brought up the speed. The picture shown is the speed range we used for the submitted model.
On top of this, we set steering to 30 degrees in each direction, which allows the maximum amount of mobility for our model. This allows the model to make sharp turns, avoid objects, and stay near the center with ease. We trained our model at 30-minute increments to avoid overtraining and added a few new components to the reward function, or slight changes in parameters each time. This tweaking showed us how to best improve the model.
For example, when I saw my model's completion percent was plateauing, I took a look at the simulation video and saw it often swerved erratically. I realized I needed to enforce smaller steering angles and steering less often. So I changed my reward function to include these factors and trained the model again for 30 minutes. After watching the training broadcast for 10 minutes, I realized the model was missing many sharp turns. So once again, I edited the reward function to accommodate this. The process repeated for each mistake the model tends to make, which led to a pretty robust model.
We started by training our models individually to get ready for the competition. Then, before the competition, we all grouped up into a Zoom meeting to run some of our own races. This way, we could determine the best model out of everyone in the group, and that would be the model that we used for the competition. During the meeting, we also decided to run 2 races instead of just 1 race. This helped to improve consistency in our results and reduce the factor of luck. We achieved our goals by starting off working individually. Since some people in our group also did the AWS Deep Racer competition last year, we had some models that we could take inspiration from already. We also had a Discord server so that we could communicate with each other easily if we had any issues. And once the competition got nearer, we put our models to a test together as previously mentioned in a Zoom meeting.
Thank you for listening, and thanks for hosting the Deep Racer event.